Good afternoon, good morning, good evening, wherever you're joining from. Welcome to Hadoop with the Best. My name is Andrew Saltis. I can give a presentation here on stream processing meets Hadoop. And I think hopefully set the stage for what you'll hear the rest of the day as other presenters talk about Hadoop, talk about stream processing, and really kind of where things are heading. Everything is being recorded, so you get a chance to go back and listen to it again if you like, and possibly have access to the slides. I'll have trouble being able to answer questions during the presentation, just the way the chat is set up. So at the end, we'll leave some time for questions. Probably talk for about 40 minutes, 45 minutes or so, and then have some time for questions at the end that we could get to. All right. So give a quick outline here, just go over kind of an introduction. Kind of the way I look at it is this pre-2012 era, if you will. 2012, 2015 is kind of this dawn of this new era related to streaming and Hadoop. And then 2016 on forward, this brave new world that we find ourselves in. A little bit about myself. Again, my name is Andrew Saltis. I'm a principal data engineer at Shutterstock. Some of the stuff I'm involved in, having fun outside of Shutterstock, sometimes ramble on Twitter, admittedly. Not about everything I'm eating or little nuances here and there, but some things that I find interesting, and sometimes perhaps not as much as I should. Finishing up writing a book for Manning titled Streaming Data that kind of covers, I wouldn't say everything we're going to talk about today, but really goes over building those larger data pipelines and what's involved in building a streaming data pipeline. I've been dreaming about streaming since sometime around 2008. Kind of first built a real-time analytics solution sometime early 2009, had deployed Storm in production around 2011, right after it was open sourced, in building a system that we were doing about 1 billion events a day. So it was kind of a fun time with Storm back then. And then I fell in love with Spark when Felix Baumgartner jumped from the edge of space on October 14th, 2012. So kind of one of those crazy things, remember it? I remember the environment I was working in at WebTrends. Felix jumped, largest amount of traffic ever seen. Analytics systems at the time had a lot of trouble processing the data. And that week, Spark was released with its own standalone resource management. So we started playing with it, and one thing led to another, and it was a love affair that began then. And I think it's accurate to say, too, that I do live in a fairly lacrosse-crazed family. So not working or playing, someone's throwing a lacrosse ball around somewhere or taking in an event. So this is my home office here out on the edge that I'm talking to you from today. Actually, I wish it's not, but it would be great if it was. So a couple of things just to kind of get things started, why streaming? And this is a great quote, I think, from Dana Sandhu of SQL Stream. Without stream processing, there's no big data and no Internet of Things. It's really interesting when you think about it, and I think, depending upon your slant, you could argue, is that really true? Is there really no big data? I mean, we're still going to collect everything. Is there no Internet of Things? We're still going to collect a whole lot. But it's what we do with that, and it's really being able to process that data. And I think it does capture that in this quote. If you look at some of the things we could do when you do stream processing, you have operational efficiency. So 1 extra mile per hour for a locomotive on its daily route can lead to $200 million in savings. And that's from Norfolk Southern of what they've done. You could predict machine failure, something that GE does with their Predix platform. That's a stream processing platform. They monitor over 5,500 assets from over 70 customers globally. And they have this very interesting architecture where it's a hybrid on-premise and cloud, that they have these plants and these manufacturing environments with GE hardware that is collecting data in the manufacturing center and sending it to the cloud for analytics. So you're able to predict the failure and determine when something needs maintenance. As an example, a single gas turbine produces about 1 terabyte of data every hour. Tremendous amount of data. So I think together we face a problem It's a shared problem that we have to figure out how we're going to solve going forward. And it really kind of boils down to this. If you had today a byte of data was equal to a gallon of water, you could fill an average house in about 10 seconds. By 2020, it'll take only about 2 seconds. That's a tremendous difference in the amount of water flowing. And really, it's the amount of data that's flowing through. A lot of it comes from Internet of Things, or as folks from GE like to call it, this industrial internet. I have a little sensor tag. It says TI Smart Tag. It fits, so about the size of a book of matches. It has 10 sensors on it. It could do IR, ambient temperature, humidity, has a barometer, has an accelerometer, gyroscope, light sensor, a whole slew of things. Cost under $30. Size of a book of matches. And they're going to get smaller. This is a graphic I love that's from McKinsey, 2015 report they came out with. They identify these 9 settings that they look at where the Internet of Things, IoT, is going to have an impact and where it will going forward. Some of it is far from even happening yet. But they look at here, when we look at things like home, doing chore automation security, that being worth around $200 to $350 billion. Security and energy in offices, looking at factories, the operations and equipment optimization, being $1.2 to $3.7 trillion. In retail, automating checkout, on work sites, human health and fitness. It wasn't too long ago that no one knew what a Fitbit was. No one had it. The President of the United States now, his watch is a Fitbit. So it really wasn't that long ago. If you're a runner, and most recent version of Runner's World, right on the cover, how did we go from being like Fred Flintstone to Fitbit in just a handful of years? Amazing. All that data that's now flying all around us. And look at outside logistics and navigation. And then cities, smart cities, and public health, transportation. Really, you look at everything around you, and they peg this at these 9 different settings of having an impact of $3.9 to $11.1 trillion per year in the next 9-10 years. It's quite impressive. So let's look kind of a pre-2012, kind of what the state of the union was, kind of what was going on, where things were happening. And you kind of have this, this making of a perfect storm. We had Hadoop. It was around long before then. The Google paper came out in 2003. MapReduce was simplified data processing, came around 2004. Hadoop became a sub-project in 2006. It's just, a long time, right? Yahoo had Hadoop running on 4,000 nodes in 2010 with over 70 petabytes of data that they were processing. Facebook had 2,300 node clusters. Hive, Pig, those graduated, and HBase was around by then as well. So in 2010, we had a lot of this stuff, right? For some people working in this space, it's like, well, we already have this huge way of managing data with these massive clusters. But it really wasn't, trusted in an enterprise fashion, right? It really wasn't until Hadoop became a little bit more mature that people felt okay putting more and more of their data in it, in the more traditional enterprises. We had Cassandra, around back then. And then 2010, you have that version 0.6 of Cassandra where there was support added for Hadoop MapReduce, right? So you start to see this, right, where you had Hadoop, you had MapReduce that came around. So you have all this batch processing, everyone kind of replacing batch processing, a new way to process data, right? With the smarts, right, of taking the code and moving it to the data, all of a sudden became a very powerful paradigm. And it is a very powerful paradigm even today. And they had Cassandra with this way of getting quick access to data and more real time. And then right on the 2000 time frame, all of a sudden, so how do we get data out of Hadoop faster? Well, we have Cassandra. Can Cassandra support Hadoop MapReduce and have this real-time world? So kind of this, how do we get back to having, the OLAP and OLTP worlds? How do you get back to having two workloads on one platform? Kind of the, nirvana, if you will. So that was all kind of going on, before 2012, leading up to that. Then in 2011, Storm was released around September 2011. So the first, stream processing, if you will, for the masses. And there were people doing stream processing before. Like I said, I was involved in building real-time systems before that we were processing streams of data. We were gluing things together ourselves or building a lot of it, but it wasn't as well, I would say, generalized as you find with Storm. Right. So for whatever knocks people have against Storm, hats off to Nathan for really kind of showing people how to get started and taking that initial step and laying that groundwork. And right around there, you get Kafka that came out. So you gotta have this perfect storm, if you will, these technologies of people starting to collect more data. There's tweets flying around everywhere. There's a lot more clickstream data. There's Cassandra out there, more people adopting Hadoop. Storm comes out, so now you have a way to hook up to this Twitter stream of data and start consuming data, or another source of data that you may have, very easy to plug into. And then Kafka's there as a place to drop it off to. And you still kind of got these multiple worlds, right? You kind of have this Hadoop world, you kind of got a little bit of Cassandra, you got streaming happening with Storm and with Kafka, and you're kind of stuck, right? And towards the end of 2011, Nathan Mars kind of coined this term of this Lambda architecture, and how do you bridge this world, right? How do you get back to that? And I think this is, a graphic that he had come out with in his blog post about that, right? And it was really this new data coming in, Storm processing it, and then going to Cassandra, or it could have been anything else, right? This is a generic architecture, just happened to be his idea, and then querying it. And then in the bottom, you have Hadoop going to ElephantDB, which was just another data store that provided access to data efficiently for read-only. So I know like Nathan had coined this, right? Of being this Lambda architecture, we have the speed layer and the batch layer. And it really kind of continues to go back at that, original thing of users want to know, and especially now, and as the world goes forward, they really want to know what's happening now and what happened 1, 2, 3, 4 months ago, right? So you see that ElephantDB route is, again, that's in front of Hadoop of Hadoop's not fast enough. That's not necessarily Hadoop at the global, thinking of all of it, but it's how do you get data and query Hadoop fast enough? Still wasn't there, right? And as we talk going forward, we'll see kind of where it is. But even then, not there, but you would push data out to something called ElephantDB or another system, and you have a general query. So you kind of have the streaming, and then underneath kind of, the Hadoop. So we saw how we tried to have the first collision of Hadoop and Cassandra. Not a lot of uptake, the implementation, it worked, not kind of the best experience. And then you split again, you have kind of this Storm route, streaming data that maybe go right into Kafka or into Cassandra, and then you got the Hadoop route, right? So there's two paths going. So that kind of set the stage for where things start to go. I think kind of this time frame of 2012, 2015, and I really kind of call this like this dawn of this new era of all of a sudden, the lights come on. A lot of people are like, aha, now we could do this. And you get back to this, all the data, looking at the data, right? It's interesting. Approximately 1% of data from an oil rig that may have 30,000 sensors is actually examined. 1%, right? And normally today, we're using this data for anomaly detection and control, but not optimization and prediction, where the greatest value arguably lies. All right, so this is from the similar McKinsey report of just how to use the data. It's this stream processing that's going to allow us to use this data. This is very interesting. I spoke with someone last summer that works for a energy firm and a utility firm in Missouri. And I was talking to this young lady, and she said that they're really kind of scared because they're so used to collecting data once a month. They get one record from your meter, and they had this whole warehouse set up, and they know how to process it, and life is grand. But now they're deploying smart meters. And for residential customers, it was going to be a meter reading every 15 minutes. And instead of being the same meter structure they're used to, it was going to have a whole bunch of other data about what else is going on in your house or what's using energy. That's going to be every 15 minutes from once every 30 days. And for commercial customers, it's going to be resending data every 5 minutes. So you're scared. What do you do with this data? How do you process it? How do you make sense of it? And it's that stream processing. But again, we need to store it. And that's where we end up with Hadoop. So how do you get these worlds together? And it's just growing. If you look at this, including smartphones and computers, it's currently estimated we have more than 9 billion devices connected in the world. McKinsey pegs it in the next decade of being somewhere around 25 billion. Cisco, they also include a lot of other devices that are kind of behind the scenes, if you will, for most people, a lot of the networking gear, but they're looking at about 50 billion devices. So it's somewhere in the middle. McKinsey may look more from what we see or what the consumers see, and Cisco looking down at that lower level. But there's a lot of people that work at that lower level, right? You see a lot of stuff of storage networks or software-defined networking, and a lot of these things happening that are driven by software, a lot of data to process. So what do we get in this time frame? It's 2012, 2015. And we'll go through each of these in a little bit more detail. We got Yarn, another resource manager on Hadoop. It's really kind of become like the data operating system, better file formats in SQL, and a stream processing invasion. So let's look at Yarn at first. So this is from Hortonworks. I think they do a good job of kind of laying this out. And you can plug in different technologies here where there's a script or the SQL, but it really shows how you have Yarn as a data operating system, and you have HDFS underneath it. And you really look at this whole thing as this Hadoop ecosystem. And you start to see products that now come out that are Yarn native applications. Things like Spark run on Yarn. Storm running on Yarn. Obviously Hive and Pig and everything else starting to run on Yarn. So you start to have this as this data operating system, almost a containerization, if you will, for the tools that we work with and for the data tools that you may work with in the future. And it kind of forms this huge ecosystem. And I would term this the Hadoop ecosystem. When you look at some of the better formats and how do we get closer to what initially was tried with Cassandra and MapReduce of getting back to having everything in one. Right? We keep going back to that. We were there, we tried it, we diverged again with the storm route and kind of the Lambda architecture, and there's a lot of energy and a lot of push to go the other way and get back there. And it comes from both directions. It's coming from, we go back one slide, it's coming from the bottom up of getting faster and better file systems. And it's coming from the top down of these different tools you put on top. Spark, Storm, and others that we'll see that fit into those spaces. Just making Hadoop faster with file formats. Out came ORC. ORC put together by Hortonworks and Facebook as an optimized row columnar format to make querying on Hadoop faster. You have Parquet, another columnar format driven off of the Dremel paper that Google came out with. And again, the idea, a more optimized file format to query data coming from HDFS. And then a new entrant that Cloudera has put out there is called Kudu. And if you haven't seen that, it's very interesting. and they're looking at totally changing how storage is done and driving things to be much faster. And they'd like it to be that type of storage that you could write data very quickly and read data very quickly. All right, they're looking to fill in the gaps in Hadoop storage layer. Right, they see that everyone's been stitching things together. This next one, in this next list here of making Hadoop faster with SQL, right? SQL is the Laguna Franca of business. All business users know it. People try and come up with different dialects, different ways of querying data. When it comes down to it, SQL's been around for a really long time. People understand it. It describes what you want to do. There's extensions to it to support things like streaming. You take a look at the Apache Calcite project. There's a lot of tremendous work going into there to support SQL streaming. So a lot of work going into SQL. And with that, you see all these projects that are everywhere, right? We've had Hive for a while now, but you see things like Presto that came out of Facebook. So, and looking at being able to use that to query Hive, query Cassandra, query different data sources for, again, fast access to data. You have Kylan, that's from eBay, providing SQL interface, over HBase, stores data in HBase, but wants to be an OLAP tool. So now you got these pieces of cubes stored in HBase, so trying to provide fast data access to data stored in Hadoop. The Apache Phoenix project, built on top of HBase. So you got more. You got Spark has Spark SQL, where now all of a sudden it's like, wow, I could use SQL to query anything. You have Apache Drill that's out there. Another interesting one, Apache Tahoe, designed for low latency. I think Apache Hawk. This used to be a Pivotal's Greenplum product, donated to Apache Foundation. And then you got Impala as another. This is going to leave the data in Hadoop. And now let's get back to that paradigm we have with MapReduce, where we move the code closer to the data. Apache Hawk and Apache and Impala do just that, right? They try and get the code close to the data and query there. So it becomes really interesting. And I think if you were to read the description of some of these, and I'll read you one of them, in a class by itself, only Apache blank combines exceptional MPP-based analytics performance, robust ANSI SQL compliance, Hadoop ecosystem integration and manageability, flexible data store format, and all natively in Hadoop. So you read that and that could be any of these products. Everyone's after that same goal, right? Everyone wants to get SQL on Hadoop at speed with data moving at speed. So streaming data that we can now query with a language that everyone knows and get access to what's happening now and what happened in the past. Let's take a look now at the pressure coming down from the top of this stream processing invasion. So it's the same thing. Again, so Nathan kind of kicked it off with Storm back in 2011 and got people really thinking about it in a generic sense. But since then, this 2012 forward, you've got Apache Spark and Spark Streaming. You got Apache Flink, which came out. And you look at these, you look at just these two right here, and they're trying to bridge both those worlds as well. Apache Spark is batch and streaming. And some people say it's not really streaming, it's kind of micro batch because it has these increments and so forth. It's true, that's fair, but what is real time, in a lot of people's worlds? If you could execute something every half a second, would you still consider that a streaming flow of data? In a lot of cases, it makes total sense and is very applicable, and you don't need it at less. So works just fine. Apache Flink, same thing. They're a consistent streaming, just like Storm. Always a constant flow of data, but they're also going after batch. So now you had this Cassandra Hadoop attempt to put the workloads on the same nodes and try and process them together. So now you got the frameworks above, Spark and Flink, for example, that are now saying, hey, we could do this at this layer, We have batch and then we have streaming. So now you kind of get both together with, again, one API and possibly using SQL. Apache Samza, Kafka has become the predominant tool of choice to stream data through a pipeline and playing that intermediary role. Samza latches right on top of that. It provides tremendous ability for you to process a stream of data through Kafka. And again, the SQL, as I mentioned, take a look at Apache Calcite, and you'll see the SQL work going on there that's being driven by the Samza team to have extensions to SQL to support streaming. You got Apache S4, which came from Yahoo. You got Apache Apex, which is a data torrent product that was donated to the Apache Foundation. An interesting one, the eBay released Pulsar. And this is interesting because it also provides a UI as well. So you get a full suite, if you will, of the stream processing and the UI. As I said, there's lots of knocks sometimes against Storm. Twitter ran with it for a while. They've released Twitter Heron, which is their replacement for Storm, of just the problems that they saw and some things they wanted to overcome, and just the next generation of where that's going. And then something that's really exciting is this Google data flow. So again, we start at the bottom with Hadoop. Everyone's putting their data into Hadoop or sometimes into S3 and processing Hadoop. You have data, the data operating system of Yarn. And you got all these tools that have been developed from Storm, Spark, Flink, Samza, and S4, and Apex, all these to do stream processing, all with slight twists. A lot of them understand SQL, not all at the same level. All have different APIs. Google released Dataflow, which is an open source product now, and as released as Apache Beam, and has that available to the masses as well in their hosted environment that you could do stream processing. And it has a slightly different twist. And we'll take a look at Apache Beam and kind of talk about that here in just a couple of seconds. So now kind of enter this, new world. We've got all this stuff that came about, from starting in pre-2012 with Hadoop and Cassandra coming out there and trying to help do it. Cassandra being the tool of choice for storing streams of data and where to put them, because you could write very fast, you could read very fast, really kind of works in that world very well. You had Storm coming out, Kafka coming out, and then all of a sudden this explosion in the last handful of years with all different streaming tools. And now we're kind of left with, we have this huge mass of tools to choose from. Whether you use Spark or Storm or Flink or Samza or Apex, or what do you use and how do you move forward? Kind of this new world, if you will. And there's tools that have come out since. So you have like Apache Gear Pump, another take on streaming. And I think you kind of start to see this streaming refinement. This is a real-time streaming engine that they were inspired by some of the changes that you've seen in the Akka framework and Akka streams and trying to push that. And they thought that they could improve on what's come before it. All right, so you see this improvement and just, we're going to do it slightly differently. We're going to leverage Akka and we're going to do something a little bit differently. And they handle what people are after too, as far as exactly one semantics, dynamic topology updates. So really kind of learning from that past, but they maintain Storm compatibility. Apache Beam is the donation from Google of Dataflow to the Apache Foundation. And this, I think, is very interesting in where things will go as we go forward. Beam aims to be the consistent API across streaming platforms. So they want it to be, and as it is today in its beginnings, is a framework that allows developers to be really productive without having to worry about the data platform, the data streaming platform you're going to use. You take what we have today of all these tools that are out there, And even though they kind of speak SQL and some of them have different degrees of support for it, even if you're not using SQL, all the APIs are different. It's kind of like the old days of doing programming against Oracle or Sybase or SQL Server or Informix without using something like JDBC. Back in the, earlier times, it was you used Oracle's tools. You wrote against Oracle code, or you wrote against SQL Server, and maybe you used their native stuff, or you wrote against a different database. There was no consistent way. There were companies back then that would sell tools, right? And to the folks that grew up in the native world of writing C++ applications against databases, you had tools like Roadway to get access to databases. You had the advent of Java and you had JDBC, and all of a sudden it was like, hey, I could just switch out which database I'm talking to from a property, and as long as I follow ANSI SQL, I'm good to go. And it doesn't matter to me what database I'm using. And the streaming world today is kind of like the original relational world of, my gosh, if I am using Apache Spark and now I want to switch to Flink, it's a completely different API. Some of it, the guys that have, and the gals, and I use guys that just in general, but the folks behind Apache Flink have been really good at trying to keep the API close to what you see with Spark. But there's differences for sure, and it's not the same tool. So there have to be differences for them to have an API that makes sense for their tool set. So really different. And then Storm, completely different than both of them. Apex, different. Salmza, very different. Some of these tools are conceptually different. They all have different APIs. They'll have their version of SQL support of various degrees. And it really makes it hard, and you almost face this lock-in of either if I go with Spark, then it's really hard to switch to Flink. And you either end up in this analysis paralysis of which tool do you choose, or you jump in with one and you're like, okay, that's it, we're using this, and we can't switch. Or you just use SQL and you may be only touching on the surface of what the tool is. So Apache Beam aims to change that. And I think as we go forward and you look forward, that is where we're heading. It's going to have to happen that we end up with a consistent view of the world, right? We're going to need developers to be productive. And the same person I had mentioned earlier that I talked to last summer that works for a utility company that dealt with all this data that's now going to be flooding their environment. We were talking about Spark and about Spark streaming. And her comment was, I don't need to hire. I can't hire all these people to write Spark code. I need people to work at a higher level, right? So I think you're going to have that JDBC equivalent for streaming, and that is going to be Apache Beam, or something that's going to be really close to it. It is very based on data flow. If you look around and look at Google data flow, and also take a look at some research originating with Microsoft that's on timely data flow, everything moves towards doing this. And the beautiful thing about Beam is even today, you could write a single application that runs on Spark, runs on Flink, or runs in Google's cloud on their Google data flow. So you could use Beam to do that. And again, the idea, similar to JDBC, you write any application with a consistent API, and then you could run it on a different runner when it comes time. So it really helps to close the gap in being able to understand the tools, and helps to make developers more productive. So it's a very interesting thing. Apache Quarks is brand new, donated to the Apache Foundation from IBM, and this is also another direction you'll see things moving. Okay, so I think if there's two things you take away of where the world is heading, besides the fact that we're going to continue to see more and more data everywhere, and we collectively have a massive problem to be able to solve, and a lot of fun, honestly. Right? What a fantastic time to be involved in this world of having access to all this data flying everywhere. It's nirvana, right? You got Beam that provides a JDBC. You got Quarks that takes this approach of saying, you know what? we're going to reach a point, and it's not too far out there, where we cannot move all the data to a Hadoop cluster, to a central processing facility to process it. We have to do analysis closer to the data because it's just going to be too much data to move. Quarks is that direction. All right. It solves that problem of where you have all these Internet of Things being pushed out to the edges, and we want to extract meaning from it. We're going to need to process data at the edge, not in one central place. And Quark is, and their site is, I think it's like Edge, it's Quark-Edge, I think, at Apache. It is processing this IoT data in the stream at the edges, and we're going to have to get there. And Beam, again, we're going to need to collectively as a community build that out, work towards building other runners. How do you make it so that I put down to solve a streaming problem that my company is facing? And I could use Apache Beam or whatever the next incarnation that takes that idea and runs forward is. But I could take that concept of I write once and I run it on any streaming platform, and I could decide, do I run that in my cluster that is my local, and local I would use more as being your analytics data center, if you will, or at the edge, and allow that to be one API. We got to get to that point. And there's one other thing we're going to need. This is all still talking at the UI, right? Or, sorry, at the API and at the developer side. The next thing the person I talked to told me was, besides having people to write code, I need better tools, right? This is a pipeline design snapshot from StreamSets. And I don't know if we'll end up looking like this. This is just what StreamSets has, but it's like this, right? If you remember, before you started to use some of these Hadoop tools, if you ever worked in a data warehouse before, in the pre-2000 timeframe, you dealt with ETL tools. You may deal with ETL tools today. They haven't gone away. People are still using them. If you grew up in a Microsoft world, they have SQL Server integration services. It is drag and drop, build my pipeline. Build my ETL is what you've done with data warehouses for decades. We need to get to that point from streaming as well. StreamSets is one take, and they have there's other companies going in that direction as well, of where do we go? How do we go above it? Imagine being this tool vendor, and now you have to worry about, how do I have developers put in support for Spark? How do I have them put in support for SAMSA, or for Flink, or for Apache Apex, or for S4, or for Quark? How do I do that? That is a monumental task to do, and a development hurdle of how do you do that and manage all those APIs. Again, you put Beam underneath this. Wow. Imagine what you could build. You have a consistent way of thinking about a streaming processing platform, and you could change them out for whichever one meets your needs, but you think about it and you develop against it in one way. Building tools like this will become much easier. And when we start to have tools like this move forward, and the ETL vendors start to look and do this, right? They're all supporting Spark now, right? Spark is undeniably the poster child for ETL. And rightfully so. The stuff that's gone on is fantastic. It is amazing, and it's paved the way for a lot of other tools. But it becomes this amazing ETL product, and as you have vendors that start to plug into there, you get tools like this. And then once you could take a tool like this and go back to the person I had a conversation with in Missouri that works for a utility company that now wants to be able to process a stream of data and doesn't have an army of developers to learn APIs, but has business analysts. they could stitch together a workflow to process this data that's coming in. This is where we have to go. It has to go towards this direction of having these tools, of having this common API, of processing data on the edge. And I think as you listen to the rest of the conference today, you're going to hear some amazing talks on how to do more stream processing, how to solve very critical business problems, processing a stream of data. There's a lot of rich things happening in these lower levels. The innovation in Spark, in Flink, in Samza, at that stream processing level, that innovation is far from over. There is so much still yet to tackle and do. And the exciting thing is, wherever your passion lies, whether it's at that low-level file system with Hadoop, whether it's at Yarn below it and doing resource management, at the file system with Hadoop, above it at the data processing layer with Spark, or the OLAP tools that you saw, or more of the SQL tools, or it's above that yet at Apache Beam, or it's above it at the stream sets. We have this entire stack that collectively we have to solve, and there's a tremendous amount of work left to be done and a tremendous amount of innovation to be had at all levels of that stack. Greatly appreciate your time. Again, my name is Andrew Saltis. You can reach me out on Twitter. Feel free to connect with me at LinkedIn. I work at Shutterstock. If you're interested in these types of technologies, we are hiring. Feel free to go to shutterstock.com careers or ping me directly. Either way works. We'd love to continue the conversation. And I'll go ahead and stop the screen share now so I could answer any questions if we have them. Thanks for being able to answer out loud. That's great. I should have done that. Let me take this next one here. You mentioned many tools that are very sophisticated and lean towards processing large amount of stream data. What tools are best for applications such as simulations that generate a lot of data during simulation? Looking for tools equivalent to cluster operating systems for scientific computing, such as Slum, TorquePD, SunGrid, etc. And I apologize for not speaking. I don't know why I just took to typing. It's a great question. I'm not 100% sure of some of the tools in that simulation world. I haven't used some of them, but I would think if you're able to stream that data to anywhere, and that could even be over a network socket, you can use something like Spark for that. You could hook Spark up to a socket and easily get data off of it. You could do a variety of things with it. You'll have the same thing and be able to consume data from Flink or with other tools as well to get data off of a network socket in any way that you need to. You take this question and see here, it says, what are the difference between batch processing and stream processing, and are they comparable? So batch processing is data that's at rest. So you're going to go and look after this conference is over. Someone could take this transcript and they could look and figure out what was the sentiment, what were the questions. You're processing stuff in a batch after the fact and on a scheduled basis. So nightly, hourly, daily, monthly, in a batch. The stream processing is as the data is moving, as the data is flowing, as there are tweets that are happening, what is the sentiment of users right now? As people are browsing a site, what are they doing right now? So the stream is as the data is moving, never at rest, and the batch data is at rest. So in projects that I work on, someone asked projects I work on, the tools that I use, Spark, I've done a lot of stuff with Storm, a lot of stuff across the JVM stack, stuff lately with some stuff with Rust, just because I tend to, which may not be surprising, as I love things that are streaming related, I kind of have this need for speed. And I've really been fascinated with Rust lately as far as getting closer to Metal and doing things faster, processing data coming in off a network faster. And looking at a variety of these tools, the entire Hadoop ecosystem, and use a variety of projects across, a variety of tools across all the projects I'm involved in. There's a question of, are we able to do real-time data processing? We certainly are, and people are, for sure. And regardless of where that's happening, whether that's happening on a vehicle, of where that's happening, whether it's clickstream, so it's soft real-time, if you will. I click on a page and how fast until you can actually analyze it. Sometimes that's, it's within seconds. But you look at the world of what's happening in automotive and supercomputers that are on board and processing data happening right then. Okay, so if you look at that, there is doing analysis on the data source in the car of what's happening. Next question here, we're currently evaluating the Hadoop ecosystem. See how it can serve the needs of traditional batch warehouse, which is on Teradata, financial services organization, the financial services organization, transactional data itself is growing like anything. I could only imagine. So how and where we take a look at real-time processing versus batch processing, as in what could be good business use case to start as example. So financial, the first thing I could think of from a stream would be fraud, right? So you think about fraud right off the bat. That'd be an easy one to look at. What types of fraud decisions could be made? How can you watch the stream of data and determine what's happening? How could you figure out what's going on? Is this fraudulent activity? What are people doing? That would be an easy one to do. You could also then go, and I don't know how this works in the financial services world as far as regulation, but if I'm out using my credit card and I'm walking around with my phone, well, you start to know a lot about me. And you probably know a lot of the merchants I'm visiting. So there's a lot of opportunity there, I think, to integrate with the merchants and provide them access to tools about understanding their customers. A question here, how can Spark be used as an ETL equivalent? It's a great question. You run Spark and Batch, and Spark has full support for Java, Scala, Python, and R. And so anything that you could express in Spark, and obviously anything you could express in Scala, in Java, in Python, you could execute in Spark. Whether it's a machine learning using MLlib, whether it's doing processing in R, whether it's doing graph processing, or whether it's just a computation that you want. And you could run Spark in batch mode. So if you have a Hadoop environment and you're using a scheduler like, say, Oozie, you could schedule Oozie jobs that have a Spark component to it, that you could have a Spark task that gets executed and do whatever work you need to of reading data, say, from a raw input source in HDFS and transforming that data and writing it to tables that may be in Hive, or writing it out to a relational data store. I've been involved in projects that have taken data, processed it in Spark that was coming in Hadoop, process it in Spark, and export it to SQL Server. So Spark kind of sits in that middle. I wish I had the diagram handy. I don't. There's one you could find if you look at some of the Spark presentations. You'll see the Spark's in the middle, and it has input and export from everything. It is very easy to connect to new data sources, both to ingest and to push data from Spark. Summarize different layers in data processing, starting from Kudu to stream data. Certainly. So you got Kudu at that bottom layer, right? And this would be, start with 2 layers, okay? So let's imagine that at that bottom layer with Kudu is down here, and really kind of have 2. We have Kudu and data at rest. So that could be Kudu, it could be Cassandra, it could be ORC or Parquet, although keep in mind, ORC files, Parquet files, they are write once, read a lot. So you can't stream data into them, okay? Kudu is a way to have incremental changes. HBase, they would make a lot of progress there too to try and allow you to write faster, okay? So you need something you could write quickly if it's a stream to then process later. So there's innovation to happen at Kudu, and then you have things where you have stuff like Kafka, where it's streaming data through and it's not resting. So if you look at that, you have data at rest with Kudu or HDFS somewhere, Cassandra, some data store, and you have data that's still moving like Kafka. Virtually still moving, right? We know that it actually gets persisted and you need that, but it's moving at a fast enough clip that it appears to not ever be at rest. Above that, you have these stream processors. There you have Storm, you have Spark, you have Flink, you have Samza, you have S4, you have Apex, you have Quark, you have all those layers there. Above that, and Google Dataflow is there as well. Above that, you have things like Apache Beam, which are going to be those APIs. Arguably at that same level as a stream processing, off to the side, you have all these supporting libraries. You know, there's more machine learning libraries that plug into these data tools, okay? But above it, you'd have Apache Beam where you have this common API. And then above that, you'd have the ETL tools and the ways to either visualize in a dashboard, which is very powerful, or to construct all these pipelines of how do you process that data from below. Hopefully, I think I answered your question. Next question, how do you think the adoption, lack thereof, of streaming platforms by Hadoop vendors, such as Hortonworks, Cloudera, MapR, into their production supported stack affect the survivability of the nested stream technologies and more conservative IT environments? They're looking to implement and well-supported stack and move on. So everyone supports Spark now. You could get Spark on Hortonworks. You could get it as part of HDP. It is shipped as part of it. You could get it as part of Cloudera. You could get Spark as part of Cassandra Analytics from DataStax. So they're being supported and they are being pushed forward. You could, if you weren't using one of those vendors, but say hosting in the cloud, you have access to this via Databricks, having Spark in the cloud and their cloud offering, so you don't have to worry about it. You have Google with their data proc, where now they host Spark in the cloud as well as their stream processing with Dataflow. So there is support for it, for sure. There is support across the vendors for Spark, for Flink, for Storm. It's being pushed and available in their distributions. Yeah, next question here is Spark and Scala a good career move for a software engineer hoping to get into data science field? There's a lot of data science access there. There's a lot you could do. I would say, is Spark and Scala a good career move for a data engineer hoping to get into data science? Probably more important than the language is going to be understanding some of the tooling that's out there. If you look at R, predominantly used for data science. So I think that's a good direction to look at. You could see everything that's happening there. Python is an extremely popular tool set for data science. Spark has full support for it. So that's another reason to go ahead and look that way. Spark and how you process it could be very powerful for data science. I'd look at Spark. I would not shy away from Flink. I'd look at some of the stuff you could do from R, Python, Scala. There's nothing wrong with learning that. If you learn one language on JVM, it's pretty easy to pick up another one. Got last question here, and I know we have another presentation that's going to start in a moment. Hi, I'm a student, very interested in Java's related field under big data environment. Which skill set do you think are must have? I would say start understanding that stack. Understand the play of Hadoop, understand stream processing, understand what you could do with it. There's lots of data out there that you could start to consume. It's very easy to take Spark or Flink, hook it up to the Twitter stream, start consuming data. There's lots of things to do. Reach out to me. I could point you in some different directions as far as data sets as well if you're interested, or some project ideas. There's lots you could do. I appreciate your time. I know we're about to go over here. Thank you guys very much. Enjoy the rest of the afternoon, morning, or evening.